Hey, what's up, everyone? Welcome to SolidWorks Live Design. SolidWorks Live Design is a series that we run here over at SolidWorks that is dedicated to the pursuit of learning from one another using a medium of like live demos and exploration as we share our favorite software tips and tricks. My name is Mike Sandy, and today we're joined by a super awesome guest. If you haven't checked out his channel, Engineezy on YouTube, you got to subscribe. It's one of the funnest channels out there to watch. Jay here, he's an engineer, he's an artist. I think he calls himself a engine artist, artisteer. I don't know. He combines both of these skills. Yeah, it's so good. And he creates these mechanical art pieces that showcase off beauty of motion, all while exploring things that we touch and feel every single day. Now, Jay, I want to ask you here before we dive into the actual content of the episode. Can you give us kind of a rundown on some of the things we're going to expect to see today on live design?
Yes, definitely. So today, the main topic of conversation is you're starting a project and you have a million different things that are involved in this project. By a million, we'll call it four or five different things. So the question is, how do you break a big project down into its little parts, 4 or 5 different sub-projects? How do you work on each one of those projects individually? And then how do you integrate them back into a big project? And I'll show you a quick example here. And this is one of the big projects that is actually broken down into multiple different ones, which is number one is like the track right here. Number two is the drive system. So how the balls are being lifted, how is it driving these gears right here, which is number 3, which is this whole system is selecting tracks because this is actually a clock. And then number 4 is the track selector over here, which is all connected through this cam right here. So basically, we'll jump right into it.
All right.
When I started this project, I basically had the idea to build a just marbled track in mind. And I really wanted to get the whole thing to lift with this like interesting mechanism. So as this turns, you can see like one arm connects to the next arm, which brings it up to the top, like right there, and drops the ball onto the top of the track. And that was kind of where this project began. But then I decided it'd be cool if this was a whole clock. And that was where the complexity really began, because I didn't want to just use electronics. I didn't want to just use like basic servos to control gates. I wanted the whole thing to be mechanical. And that's what all of this right here is. So the whole thing runs off of one motor, which is right here. This one motor controls this track lifting system. It controls the ball dropping system right here. And it also controls the track selection, which is this right here. Let's see if I can get all these parts to show. And let's see. You can see as this turns, these gates move up and down. That selects which track. This bottom one right here is the minutes track. This is the like 10 minutes, and this is the hours. And the way it all works, it's kind of confusing, hard to explain, but you'll have to watch the full video to see. But what we're talking about here is how did I break this down to begin with? And so I broke it down obviously into those 4 components, and I started with the track. Actually, you know what? No, I started with the lifter because the lifter was important to figure out exactly.
And which is the lifter's what lifts the ball up?
Yeah, it was actually a combo. I started with the top of the track right here, and then this is where like the hours, where the time is shown. And so I had those 2 parts showing, and then I designed the lifter to make sure I could reach basically those pieces. And then I built the track around that. So you got to start somewhere. And often there's like some sort of fixed dimension. And in this case, it was the balls that I was using, which were 30 millimeter balls. And I chose these because I wanted the thing to be big, but I was originally thinking like 2-inch diameter balls, or like 50 millimeter. And that meant that this thing would have been absolutely massive in total. So I decided to scale it down to these 30 millimeter balls, but this is what allowed me to start designing everything around that. So the overall height, the spacing that I needed these tracks to be, the width of the tracks, and like the profile and how they roll. And so after selecting the ball, I was really basically able to start designing off of that.
Jay, in terms of scale, I mean, how big is this? How big? I've watched the video on YouTube, so I've got a feel for it, but for the audience.
Yeah, it's really hard to see it on CAD. And that's like, it's funny, like no matter how many times I've built things, every time it makes it into the real world, I'm always surprised. Just there's something about
Like,
CAD, the way
whoa.
it looks. But this base right here, if we were to measure it across, let's see, it's 900. So it's 1,000 millimeters. So it's 1 meter across. And that is like about a yard, it's
Okay.
3.3 feet
Yeah.
for those who use feet.
So that's good
And
size. Yeah.
yeah, it's pretty big. And then like the height overall, I think, let's just see quickly, you can measure it, is, you can't see my measurement window, but it's from there to there is also almost a meter.
Okay.
You can
So it's
get an
big.
idea about how big it is, just kind of like a meter tall by a meter wide. Yeah, or more than a meter wide, I guess, because the tracks extend. Yeah, so like once I had like the ball dimension, it was kind of like, okay, how do I make a track? And that was actually a very tricky thing to do. Like if you've ever played Roller Coaster Tycoon, you kind of just like click tracks into place, and everything else just comes together, and it's all these like set dimensions. But when you're dealing with like just something that doesn't exist, having the ultimate freedom to do anything that you want is always tricky. So if we go into the track, and this was kind of the first thing that I designed, and this is just kind of like a side note, but when I'm designing these big mechanical assemblies, often the way I break it down is all of this is static. None of these parts are moving. And so I would design it into a multi-part file. And this one got a little bit out of hand. You can see right here, there's 107 different bodies
Wow.
in this part.
Because when you go into these, you're also designing for 3D printing, for manufacturing throughout. You've got
Yes.
that
Yeah.
kind of the forefront of your mind.
It's a very important thing to keep in mind. So here in my shop, I have 3D printers and I have a laser cutter, and I find it really like frustrating to have to go and outsource things.
Mm-hmm.
So I try to make everything that I can with the tools that I have here. And so like that's why you can see like this piece right here is actually 3 different pieces. Because I can cut all of these on my laser, and then I don't put any screws in. I kind of just remember where the screws go. But you can see everything is held together with screws. And yeah, like the whole thing, I really have to spend a lot of time thinking about exactly how this whole thing is going to come together. And like parts like this, like these are the track components. These are brackets that connect the track to these pieces right here, which are laser cut acrylic. And I wish I had the thing here. It's too big to keep in this little tiny shop. But
Sure.
if you watch the full video, you'll see how it all came together. And it's just a mix of basically 3D printed parts, which is all of these solid track pieces, and then these clear like laser cut pieces right here. And there's a lot of parts here that aren't showing, but you can see like brackets like this, where it's all screwed into the bottom of the base. This base I ended up having to make in 3 parts so it could fit on my 3D printer, and then I laser cut like a top panel. And the reason why I 3D printed and laser cut is because when you 3D print, you can recess countersunk screws. And if I was laser cutting, I'd have to go and like countersink all this stuff after the fact.
That base for the audience, because you got to go to his channel, watch the video of this, because he goes in depth on how it works, and the kinematics of it are phenomenal. But that base too has 2 rods, right? That are also,
you see those right here.
So and that was 3D printed in, right?
Those the 2 rods, I have the holes in the 3D printed parts, and I just
use the holes,
like, steel rods.
Yep.
Yeah, like you can see the holes like here, and I just jammed steel rods to kind of give it some structure, which honestly it might not have needed, but sometimes it's better to overbuild than underbuild. But yeah, so like a lot of times I'll just basically thread screws right into 3D printed parts, and from my experience, it just like works really, really well.
Sure.
A lot of people use like threaded inserts, and they heat set them in. I've never ever done that. I've never had a problem. So even just like regular metric screws, I'll just thread them right into the part, and they hold really well, kind of undersize the holes. And so you can see like some of these parts I have like with like, I've made edges transparent just to make sure I knew exactly how things were going to go together. And it's kind of complicated. You can see like here I have like, these are 2 pins, and then these are screws, and then these are screws coming from the bottom holding into the track. And yeah, so like in a project, it's not like a sexy thing to have to figure out screw holes and how everything's going to go together, but is it like one of the most important parts to think about all the way through the project. You can't just like design a track, which was complicated in its own. And you can see here, this is my feature tree. And I've actually never really been able to show this to anyone who understands SolidWorks. You could like fully, I don't know, geek out on this, but look at this feature tree. This is the craziest feature tree that I've ever made. I've never done this before, but I'm actually using folders in my feature tree to organize some of the
Great,
stuff.
yeah, great tip. I bet moving forward you'll use them more often, even with less complexity, because they are nice, yeah.
And like, you know, sometimes I actually named features, which I never did before, because there's just times where like I needed to adjust one screw hole right here, for example, and like, where is that in this massive feature tree?
So in terms of, I mean, we starting off with like you mentioned you have the knowns, right? Just like any engineering problem, we gather what we know, we gather our constraints, and then we figure out what we're actually solving for. You looked at this holistically, and prior, I know that the lifting mechanism, there's another tool that looked really cool that I've never actually heard of, the motion kind of generator. So you kind of tackled that lifting mechanism from an earlier project, somewhat repurposed that into here at a different scale. So that's like a little subsystem, right? You've got.
So, yeah, sorry. So the track is the first subsystem, we'll call it, and then we'll go back to the assembly here. The second subsystem was the lifter, and I have all of this stuff here. Yeah, it's all just the mech here. Let's see if I can isolate that so you can see it. Boom. So this was a whole other subsystem, an entirely different project within the same project. But the way I started this was I had the lower ramp of the track right here, and then I had the upper ramp up here. I knew what the dimensions were, and I might have, I don't know. I can't exactly remember how I set it up. There might be in this base a sketch that shows it, maybe not. But yeah, so for the lifter, I basically just use those dimensions, and I actually use the tool outside of SolidWorks called Motion Gen, which is like it's kind of like a sketching. It's like if you were to sketch in a notebook, it would be like that, but for mechanical design. And it was really helpful for me to just get an idea for like how adjusting each one of these dimensions adjusted the trajectory of each one of these linkages. And
so one of the questions in the chat is, did you use SolidWorks to simulate the ball's movement? And I know you use that motion gen to figure out kind of that cam path, or the tracing the path of the movement. What about, is there any, like, you start there, bring those in?
Yeah. So for this, it's, I basically just kind of use my experience to know that, like, you know, like the ball here would come through, and there's a lot of adjusting and that kind of stuff. But you can see here how like they come together, and just based on like lots of projects.
Oh, I see how it works. For some reason, I thought it did like a handoff. I didn't notice that it actually goes through to do the pick.
So you can see like the design of this mechanism is specific, that as it comes down, like it scoops under and picks up the ball, and then it comes above the upper link.
And then
so
it
can drop
has like two fingers
on the handoff. Yeah, and you can see it's just like kind of guides in between those two right there. And so you have to be very specific about the path. You couldn't just like jam them together and then open it up. You had to make it so the ball was placed down on the next hand and brought up. So for something like this, I don't use like anything. I have a motion study here. Oh, I guess that's for the whole thing. That's going to break my computer. So we're not going to go into that right now. It's breaking my computer as we speak. It's rebuilding. But I did use a little bit of motion study for, I guess, somewhere along the way here. I
mean, you could in your subsystem approach, right, or your sub-project approach, because the track, in theory, as long as we're going downhill and we know some velocities, but that like the pickup motion would be a pretty easy one to solve for using motion.
Definitely.
But using the motion gen tool, is that the name of that?
Motion gen, yeah. So it's
so check that out.
Free web app.
Not Dassault, but yeah, free web app.
Yeah.
That gives you a really good starting place, and then you can start to iterate when you get into SolidWorks.
And that being said, you can do the mechanical sketching in just a sketch as well. And I do that often, but sometimes like you have to constrain everything. And if I'm just trying to get like a really quick, like unconstrained model, Motion Gen's really good for that. But honestly, before that, I always just use SolidWorks to do this stuff as well.
Okay.
So just like a 2D mechanism sketch using just like the regular 2D sketching.
Yeah, the layout sketching, yeah.
Yeah, which works really well also, and it's also very quick and easy to do. And the one advantage of that over Motion Gen is you can use dimensions. Motion Gen isn't really parametric, so it's like very basic. SolidWorks is definitely like I
mean, it's like it looked like a moving napkin sketch, right? You could really
Yeah.
just get some ideas down,
Exactly.
play with it, see what those paths are, and then get a good starting point when you get to into SolidWorks.
exactly.
Okay, so the sub projects here, we've got the track, right? And that obviously we talked about the complexity of your feature tree.
Yeah.
Then you had the pickup system. And to me, those two I saw and I was like, okay, that looks like something I could maybe figure out in a much longer time and period than you did. But then you got into the rest of these other sub projects and I was blown away. Like just
So it's funny because it's very complicated, but also once you've designed one clock, it all starts to make a lot more sense. And it was the same way that I did make a video like 2 years back where I just designed like a regular clock. And using that knowledge, I was able to design this system, which looks complicated, but really what it is a cam system. And I don't know exactly how I've got everything constrained here. So we'll see. So you can see this cam system right here moves these gates backwards and forwards. And if we pull the track open, and maybe we'll hide this piece. Hold on one sec. We'll go here, just hide this so you can see it better. And this cam system pulls these levers forward and back, and those open and close these gates. So this lower gate will open and close. This makes a rotation once every 10 minutes. This gate right here makes a rotation once every hour.
Okay.
I want to make sure I'm getting this right. Once every hour. And then this one makes a rotation once every 12 hours. So once every 10 minutes, this opens and it dumps all the balls from the bottom track out. And then simultaneously, sorry, let's get to this view right here.
Are those done on a single motor with gear reduction, or do they have separate?
Exactly.
Okay.
So it's a single motor. The one motor is driving the entire structure. This makes a rotation every minute. So every 60 seconds, this makes one rotation. So it drops a ball every minute. Every minute. Well, so after that, this gate stays open. You can see this cam right here. This cam is a 60-minute cam. So it takes 10 minutes to make this like section right here until it gets to here. And you can see this track drops and this track opens. So that happens as this gate opens. This gets complicated, but these balls drop out. Another ball will drop into this track here. And so now you would, like with this current setup, like it would be 1, 10, 12. So it would be 112 based on the, well, I guess maybe this 113. And then the next minute goes by. This returns to here again. This gate will close again, and then it will keep dropping balls. So, you know, like really that would have happened here, you know, and like, it would be 111. So if there's no ball here,
those all go back into the pool.
Exactly. And they all go back down to here and they start again. So this was like complicated when I'm talking about it like this, but when I broke it down into its sub pieces and just worked on one of these things at a time, it was like for this cam right here, basically was I knew I needed to open a gate and close a gate every 10 minutes and then open or close both gates every hour to drop a ball into the hours track. And that was as simple as just one cam per each of these tracks. And you can see they rotate and then rotate. And then when they get to this point here, they both drop down.
Okay.
And that was like, we'll call it, I spent like a week trying to figure out this cam, the profiles, whatever worked to make it so nothing jammed too much. Like, and that was its own sub project. And then
so when you're doing that, you kind of go into that same mindset. Like, I just need to figure out moving balls into 3 tracks. What does that look like? And you're not worried about how the balls are coming in or timing, like
Yeah,
that's just your focus.
exactly. And often what I'll do is be like, I need to figure this out, and then I'll just go on YouTube and just watch, I don't know, as much stuff as I can to try to get an idea. And then I'll just like the interesting thing is like whenever I post something on like a short or whatever, there's always comments that are like, why didn't you just do it this way? Why didn't you just do it that way? And the cool thing about engineering is it's actually like, this is the art part of engineering, is there's a million ways to achieve the same thing. So this was just the way I decided to try doing it. And, you know, there's also a factor of like, how much time do I want to spend weighing alternatives? If I make something that kind of works and I can like tinker with it, iterate on it until it does work. So that's why I chose this. And basically I had, we'll call it this, completely independent from this. And I was like thinking, okay, how do I connect this to rotate once an hour? And I knew that this wheel was rotating once an hour as well. So I connected them. Let's see if I can get that back there. I connected them with the shaft, this bevel gear. So this gear, and it's going to be kind of hard to show you, but there's a coupler that is connected to this gear right here, which is connected to this shaft. So this gear and cam and this cam are rotating together.
Okay.
And that's basically, once you have that, once I had that figured out, it was like, okay, I just need a gear system to rotate this cam once every 10 minutes and a gear system to rotate this cam once every 12 hours. And that's just really like, you know, like old technology gear ratios.
Now, do you model the gears yourselves, or do you find a library of those, or where do the
So I have a gear library, which is actually available to anyone for free on my website. And it's kind of just like a bunch of step files of gears. Just I found it's just easier to use that. I used to use the SolidWorks toolbox mainly for gears, but I found sometimes when I was like modifying things, if I wasn't careful, I'd accidentally modify a toolbox component and it would just like, I don't know. I just didn't understand it well enough. That
there's some complexities in there you gotta be familiar with. So yeah, it's pretty common just to create a derived part.
Yeah. Exactly. So I always just pull gears out of my library. Anyone can use it. It's free. It's on my website, engineezy.com. But yeah, so basically like the process of breaking a project down into its components and then bringing them all back together is kind of, you know, you can see how it works here. But this was sort of done, like everything was kind of working together, you know, so I had to think about everything holistically. But we can move into a different project. And this is actually the project I'm currently working on right now. So for anyone who wanted a sneak peek of all of this marble craziness, let's close this.
While you're doing that, I'm gonna some good questions coming in from the chat. So keep them coming. One is how many. So when you're doing this on that last project, and maybe we could pinpoint it down to a specific sub project, but how many iterations do you kind of go through? I mean, is there even a count of iterations?
Or you know what? I can talk about that actually really well with this project because we can take a closer look. So what I often do, so this is the project that I'm currently working on right now. And if you've seen any of my recent videos, I've shown a video of this component right here, which is just a marble sorter. And I actually have it right here so you can see it. So often what I do is I break the project down into even smaller bits so I can just test things really, really easy and cheaply. And this right here, let's see, I have iterations. So this, like each one of these took about an hour to print, very cheap. And so I had different iterations to test. Like,
so you're actually physically printing your iterations.
Exactly.
At the smallest scale you can find.
Exactly.
To help that, just the rate. Yeah.
Yeah. To help the rate, I hate wasting material. I'm definitely like conscious of the environment, and like people do comment on that a lot, but I don't like to just like endlessly iterate, you know, like I used to work for a big company and like there was, you know, when money isn't necessarily an issue when it comes to like making materials, people tend to waste a lot. And I'm very conscious of that. So that's why I try to break things down into very small pieces. I try to recycle any filament that I can. But sometimes, and that's when we get into these, sometimes you have to print like more larger scale. And so for the bin that you can see down here, this was a completely different sub project from the marble sorting system. But sometimes you got to kind of like go full out. And I've printed, actually, I've only printed 3 of these, which is pretty good. There's one more coming because I forgot about something. But on a project like this, the different subcomponents are actually a little bit more independent from each other. So now I'm at a point in this project where I've designed subcomponents. So I have an idea for how to like eject the marbles and sense them. There's a system for sorting the marbles, which I can show you what I made for that just to do a smaller test. Let's see where are you here? So this was like a small, sorting system that I built, and that's on the table back right here behind me. And this was just to make sure that I could sort the marbles into the different bins. Okay. And I haven't even explained what this whole project's going to do, but ultimately what's going to happen is it's going to push marbles out of these bins up to the top here. And there's no slider on in this assembly yet, but there's going to be something that moves across and drops specific color marbles into this grid right here and can make any picture out of 32
cool.
by 32 marbles. And then when the picture is done being made, it will sit there for however long I decide I want it, and then it will dump all the marbles down into this bin, which will then be filtered back, which I'm obviously still working on this system here to lift the marbles back up, but it's going to be filtered back up and into the sorter and then back into these bins.
Oh, I want one.
So this is so cool project like in its entirety, but this is really just built off of like, I need a way to distribute marbles one at a time. So I just posted a short yesterday that shows how I'm planning to do that with these Archimedes screw bins, these like auger based bins. They push the marbles at the back. The plan is to have them go up a tube all the way to the top here, where there's going to be a system of spouts. I have a idea for how to make a sliding ramp system, so I can basically keep these spouts stationary and just change the angle of the ramp so they can get into each one of these things, and it's going to drop the marbles in. But each one of these things is kind of independent of each other. And so for something like this, I often just make these smaller prototypes, these little projects, which actually has 2 different benefits. One is I can actually see things come into life in real time, because I don't know, it would get like really hard to just stare at this CAD model for like 3 or 4 weeks without seeing anything working in real life, just to test something that doesn't work. So it's exciting to see it working and like seeing it come together, but also it has the added benefit of I can really like figure out each individual component, make sure that it's working really well, and kind of just jam them all together in a way that makes the whole thing work, which is it's very different from the roller coaster where everything kind of had to be integrated. This is everything can be different, but I'm going to be using a lot of electronics to make this thing work. So there's going to be,
as you say, there's got to be a controller of some sort.
Exactly.
Right?
There's going to be like probably like 4 or 5 different microcontrollers running this thing. That's mainly because I'm a mechanical engineer, and like for computer stuff, I kind of just have to hack it together. But like, you can see each one of these are a motor running each bin, which there's actually going to end up being 2 motors on each one of these bins because I want double. And that's all just with the intention of speed. There's a solenoid here to eject the marbles. And a lot of people actually have asked me, like, why not just run the marbles past the color sensor? And I've tested that, and it's just not accurate enough to do that. But each one of these holes is actually going to be powered by a motor, one of these small motors, which controls these gates.
Okay, that's where this test.
Yeah.
Test
so
gotcha.
That's going to be 1, 2, 3, 4, 5, 6, 7 motors there. And then each one of these spouts here is going to be connected to each one of these gates with a switch I've decided to go with to basically know when it's ejected a marble or not. And I think like the power of electrical or mechatronic systems, we'll call it, is that you can really make things a lot more individual than when you're dealing with like a roller coaster marble clock where everything is working together off of one single motor. But yeah, so that that's kind of the process of breaking things down into its parts and then figuring out each individual part on its own and then reintegrating it back into a main design. And like once you get to this point, this is actually I always call this like the mid-project grind, because now I got to figure out where all the screws are going to go and how everything's going to
Sure.
mount to everything and all of that. And that's there's really no secret to that other than just staring at it and
Just the
twirling and
grind.
thinking and making these like really basic shapes to like like this is not the way this ramp is going to look, but it's just a way to kind of squeeze everything together. And like in the process of doing it, I kind of was like, oh, it could be cool if this bin matches the angles of these ramps.
Yeah. Yeah. There's
And
some
like
great aesthetics to it.
exactly. And so it all sort of starts to come together. But this is a grind. This is like 2 or 3 weeks of CAD where I'm also very cognizant of how I'm going to make everything. And that's
Sure.
a very important part as well. Like if it's too big, like this piece is too big to fit on any of my machines as a 3D printed part. So I'm trying to decide, do I cut it in half and cut it down the middle? And then how do I assemble it all back together once it's all printed? And
So we got,
go ahead.
oh, I was going to say, we got two really good questions came in terms of one I'll hit on is, and this could be a long conversation, a separate live design altogether on multi-body versus part approach to it.
Yeah.
You kind of use almost a hybrid, or is there any rhyme or reason to
Yes, there is.
to how you approach that?
Basically, if it's static, anything that's static, even if it's being assembled, so we'll pull this open, for example, like, actually this isn't fully completed. Let's pull open this one because you can see it better. So this right here, none of these parts are moving relative to each other. And you can see there's the front plate and the back plate and the way it all goes together. Since this is a static piece, I make this as a multi-body part. This is 8 pieces. And then when I bring it into this CAD, like sometimes, like for a motor, for example, I'll often build the motor mount off of the motor. So you can see here, just like this. And I don't know where the rest of the parts are here. Oh, this was actually 2 different parts where I iterated, but this was the original motor mount system here. And then I iterated. So it really depends, like often I'm working by myself here. So where are you? There. I kind of have a better idea for how things are all going to go together. I don't know if this is best practice if you're working in a big team, but for me, I find it easier to conceptualize how things go together doing it this way. And then like anything that's moving, like these pieces right here, I use an extra part and I use mates because that allows me to get a better idea for how things move around. And then even like this solenoid, which I've actually modeled, this is a sub-assembly that's open at, so you can see. I've modeled the solenoid, even the plunger of the solenoid, I've actually modeled it as its own part, just so I can understand better about how it's going to like plunge in and out. But everything else here is kind of a static piece.
So multi-body approach when you have no need for mates or movement between those, and then you can break those bodies out, print them individually.
Yeah, exactly.
And then anything that has motion kinematics that involve around that, you do single part and mate them. So that's kind of is that a good way to sum it up?
That's exactly it. Yeah.
Perfect. Okay, so another good question. We got tons of good questions coming in. The other one too is on material approach to this, because I know you have multiple different 3D printers there. You also have your laser cutter. How do you decide how much does material selection or print process go into this as you're designing, or is it something that's in the top of your mind, or do you figure? Yeah, like what's that look like?
I think it's basically a top of mind for the entire process, and I think that allows me to iterate and make these things happen faster. Is like, and this also is it's like a lot of experience has gone into this. Like when I look at something like, let's open this piece right here because this is multi-material. So when I'm designing this in the first place, I'm thinking, okay, how am I going to put this together? Like ease of assembly is always important, but also there's like a factor of like color, like clear stuff like this. Obviously you need a material that's clear. And so I often will laser cut acrylic for this kind of stuff. This right here, I ended up laser cutting this panel just for speed, really. And I used a white material, which is why it's kind of like separated here. And let me grab that part so I can show you better. It's right here.
I think when you pull it up, I just want to mention, like, I think, seeing a lot of really good SOLIDWORKS users who can design just about anything, what really separates like the good power user to like the pro industry user to me has always been that forefront of manufacturability, ease of assembly, keeping that in mind and understanding that. because that really is what bridges the gap of going from what you see in CAD to actually getting it made. And as
100%.
we all know, not everything can get made that's you design in CAD.
Yeah.
So it's really cool to see your process and understand like, oh yeah, you are considering this is going to go to my laser cutter. This is going to go to this machine right up front.
Yeah. 100%. It's actually, it's funny. I was working at a toy company before this, and my job was like a prototype engineer. So I was basically
nice.
designing and building toys. We had this one engineer who was an absolute mechanical genius, but everything that he like sent to me to build was impossible to build. So it theoretically worked perfectly in CAD, but there was no good way to build it. And it'd be like things like he would have reverse threads or like a double threaded rod, and I'm just like, like how do you make that? Those parts to like design, to even manufacture those parts, you would need, I don't even know, like things like precision lathe CNC or whatever. And so for me, I have to design with the tools that I have available, which is parts I can buy stock, parts that I can 3D print, and parts that I can laser cut right now. And like one day I want to be able to manufacture metal parts here, and that would completely change my design process. But for now, I got to stick to what I have. And so, like when you come to a piece like this, which you can see the CAD, and this is the final product, it looks exactly how it does on CAD. And everything was designed specifically for like some of the stock parts that I had. Sometimes I just jam stuff in that I have available because like I don't feel like waiting for things to arrive. But it's very important for just the ultimate speed of an iteration to be able to just make it quickly and put it together. And even still to this day, there are times where I'll build something and I'll like start trying to put it together and be like, oh crap, like I completely forgot about that. Or like I didn't integrate like where the wires are even going to go, and sometimes that actually becomes like a factor. So there's still stuff to be learned along the way here. But
Jay, you've mentioned you worked in industry at a pretty big company, and now you're by yourself downstairs cranking away. Yeah. Do you like or have a preference on working solo and kind of having the reins versus a big design team?
I think it's definitely, there's pros and cons to everything here. Like I can move very quickly. I can, all the decisions I make, I can execute on, but often I get kind of like pigeonholed into my own experience and my own ways of doing things. And like when I get stuck, it's sometimes hard to find ways out of it. And then on top of that, just like it's nice to do creative things with other creative people. I think there's a lot of like a process of building on ideas with people that I don't really get to do here by myself in the basement, which I used to get to do a lot of at the toy company. There's like tons and tons of creative people there. So there's definitely pros and cons to everything. Also, I had like basically endless resources there. And here I have what I can afford and make myself. And so there's always that as well.
Yeah, I think that's very well said. I can totally agree with that from my own personal perspective.
Yeah.
Well, sweet. If there's any more questions in the chat, fire them in now. You guys have had really, really good questions coming through on Jay's process, and you've done a really good job. Like, I love the concept of like starting your project. You got lots of components, but don't get so focused on the big picture, right? Like really start to hone in onto those sub projects or those subsystems and figure those out, right? Because you understand the holistic approach, but now we got to figure out how they're going to work, and then you start to integrate them together. And you've proven it, man. Like your process is amazing because look what the stuff you're doing is just so cool. Is there anything else that you were hoping to share with us today? If there's any questions that come in, we'll answer those as they come up.
If there's any questions that come in, but one last thing I want to say to anyone who's like stuck on something is just try to get it into the real world as quickly as possible. And as an example, for this prototype right here, I like had the Archimedes screw. I couldn't exactly figure out how I was going to get it to distribute one marble at a time here. And I ended up building a cardboard prototype. Like I glued the motor to the cardboard. I had the screw printed out already, and just like added card. That was something that allowed me to like very quickly conceptualize how I was going to get this thing to work. So if you're ever stuck and I don't know, you're overwhelmed, just try and make something happen as quickly as possible. And then you can definitely find avenues you didn't think about once you've gotten something in your hands.
A lot of great things have come out of cardboard, duct tape, maybe some pins,
Yeah.
whatever,
Hot
it's
glue.
cheap,
Heat too.
recyclable. Yeah, hot glue. Yeah, there you go. I was going to ask you, is there, as we go through, I got a few last questions I had personally, because I got a chance to re-binge your YouTube channel. I recommend everyone go through the playlist, watch it all. It's so fun. Do you have, so rapid fire, do you have a favorite hand tool in your shop that you always rely on?
I do. I have an electric screwdriver right here, actually, which is the only electric screwdriver that I found that has like a clutch. And this is basically
nice.
like a daily driver. You know, I never thought I would
Okay.
need one of these, but it's definitely changed the game.
Okay, that's on my Christmas list. 3D printing, you've got several out there. If you're new to it, you're on a budget, a home guy like me, or probably a lot of our audience members. What material or where should I kind of start to figure out what would be a good first 3D printer?
First 3D printers, anything that you can afford, really. Like today, things are just so good that it's kind of hard to go wrong. But I always recommend Bamboo Lab or Prusa machines. They're a little bit more. Bamboo Lab actually has some like cheap machines, which are good. Prusa has one small machine that's like pretty affordable, and then their other machines are also like in the under $1,000 range. But honestly, anything that you can get to work. Like I started working on a, what was it? It was like a Anycubic, I don't know, i3 Mega, which was like $200 on Amazon. And this was already like 4 years ago, and it wasn't perfect, but it got the job done. And you know, like I said earlier, if you can just get it into the real world as quickly as possible, you can learn to work around how crappy or good your printer is. So yeah, that's my recommendation.
You'll figure it out. That's awesome. I think that's it, man. This was so fun. It's been a pleasure to be able to talk with you the last few days, especially today, and share this with our audience. So thank you so much for your time, as always. And I can't say it enough to the chat. You guys get out there, subscribe to the channel, check it out. If you're into engineering and design, which is probably why you're here, you're going to totally geek out on it. And Jay is just a fantastic person in general, so reach out to him as well. So thanks for going through those 3 lessons. We talked about that top project, the sub projects, and putting it all together. We learned that about on live design, as always. So stick around, I guess, for another minute unless there's any other questions. Any final thoughts you can think of?
Final thoughts, I mean, just make the things you want to make.
I love that. I put you on the spot and you just nailed it. Make the things you want to make.
Make the things you want to make. Try not to let fear get in the way, because I just find it so rewarding. And I get scared too when I'm setting out to start a big project like this. It's scary always, but when you break it down and just start creating it, like the day-to-day, like the hour-to-hour is always enjoyable. So don't stress too much.
That's great advice.
Make it happen. Yeah.
Awesome. All right. Well, thank you for coming. Thanks everyone for tuning in on YouTube. Make sure to like and subscribe to the SolidWorks channel as well. We try to bring you insightful information from power users like Jay, internal employees at SolidWorks that love to share what we've learned. Anyone else out there that's willing to dive in and spend some time with us. We'll be back next month with live design. So again, like and subscribe, watch those notifications, and we'll see you then.
Thanks, everyone.